Aishwariya and I'm in 11th grade, and I go to John F. Kennedy Memorial High School in New Jersey. My topic is CRISPR for neurodegenerative diseases, current advancements, and future applications. So, what is CRISPR? CRISPR, or Clustered Regularly Interspaced Short Palindromic Repeats, is a tool that can modify genes. And it's a very good tool because it offers precision in targeting and modifying DNA. And it holds promise for treating genetic diseases like Parkinson's and Huntington's. So neurodegenerative diseases like Parkinson's and Huntington's are debilitating conditions, and they're often linked to genetic mutations. These diseases currently lack proper treatments, making gene editing a potential game changer. So this is CRISPR, how it works, and this is how some of the genes that affect Huntington's disease. Current advancements. So far, from the research I have studied, we have been able to successfully alter the mutation in the MAPT gene in a mouse model. So, and there has been like successful modification of the HTT gene in a pig model. So far, there's only been research with animal models, and there hasn't been much research with humans, and any research that is in the clinical stage is hasn't progressed to that area yet. Future prospects. As I said, trials are already in preclinical stages for Alzheimer's and Parkinson's with CRISPR, and specifically, researchers at Yale have received a grant to begin clinical studies. What are some limitations? So neurodegenerative diseases, as I said before, are very debilitating, and for Parkinson's and Alzheimer's, only 5 to 10% of the time they're caused by genetic mutations. However, for Huntington's, they are caused by genetic mutations almost 100% of the time. And CRISPR is still in the early stages of research, as it was only discovered as a gene editing tool in 2012. So the methodology. I compiled information by analyzing research papers, news articles, and online articles, and I analyzed all this information to make a clear account of the research that occurs with CRISPR for neurodegenerative diseases, and what is going to happen in the future. And from my research, I have discovered that CRISPR is a viable option to treat neurodegenerative diseases. However, it isn't the best option. Conclusion. CRISPR has the potential to treat these diseases, and success has shown that it works, but clinical studies need to occur before it can be used as an actual treatment. And as I stated before, it can't be used for everybody. And so this is not a viable option for everyone. This is only for people who've been affected by genetic mutations. Other causes can't be treated with this. However, it's still a hope for the people who have. Thank you. And I would like to thank my professors, Professor Varkey. He really helped me discover the limitations of my research, and Professor Virgil, he helped me format all of this and figure out what actually needs to be put in this paper. And also, I would like to thank Gifted Gabber for this opportunity. I never thought I would be able to write a research paper this early on, and it's shown me all the things that are needed and necessary for stuff like this.
Great job, Ashrita. A question for, I'm sorry, Aishwariya, I apologize. Aishwariya, Dr. Varkey.
Aishwariya, congratulations and good presentation. And I know that it's a very complicated topic, but I remember that CRISPR is now the cutting edge technology, and which has already started yielding results for some other diseases, monogenic diseases. So my question for you would be, let's say, for example, you are able to very cleanly remove a particular gene, that is alpha-synuclein gene, which you find, okay, there's a mutation in that gene, and you remove the gene through CRISPR and put the right copy back into the individual for gene therapy. But still, you see that there is no change, okay, in the individual. So, what would you think could be other problem?
Well, I would say it would depend on the disease. Like I said before, like they're not all caused by genetic mutations, so this could be some other problem in the actual like
Let's say
somehow.
for Huntington's. Sorry,
Hmm.
I'll give you an example. Let's say based
Okay.
upon the lecture that you have, like you listen to, Huntington's disease. Let's say you are able to remove the Huntington's gene, the one with the kind of bad gene, and then you put a good gene. Still, you see the problem. So, what it could be?
Um, I don't think I discovered that in my research. As I said, like there hasn't been much research, like actual clinical studies into that. I would assume that it was a different area that was impacted. Um, Maybe it just doesn't have that much response in that specific person. I wouldn't really, uh, I'm not really sure, I would say.
Okay. Yeah, I know that you already know the answer. The moment I say that, you will remember that. You remember the topic when we're talking about Huntington's disease, that there are other genetic loci which also have influence on the gene, particular gene. For example, if you have Huntington's gene, there are other genes which also influence the activity of this gene. So there are some positive modifiers and negative modifiers.
Hmm.
So you might want to you might like add that into your research article where you can talk about that. Or maybe go back to the lecture and then see the particular figure that I'm talking about, where I mentioned the positive and negative modifiers of particular gene. Okay.
Okay.
Otherwise, really good presentation, and I hope that you will continue to learn more about CRISPR and how it can be used for other diseases as well. Good
Thank
job.
you.
Excellent. A question for Aishwariya, Professor Virgal.
Uh, Congratulations, Aishwarya. Great job. I just have a question. How does your topic contribute to the existing literature that we have? And why do you think your study is really important, particularly today?
I would say like I have seen some studies about um how CRISPR can be used for neurodegenerative diseases, but they don't really address that like it's not a viable treatment for everyone. And they just like talk about like how it could be used. And I feel like with the my paper it adds like another like almost like dimensions that people can like actually understand um the limitations of this treatment. But and I just feel like this is also hasn't been that much of an explored topic. So, it just contributes and adds on so that it could be more recognized in the future.